show by the principle of mathematical induction that for all n belonging to the set of natural number, the following is a true statement. Okay, let us begin. So here we will consider a statement which is denoted by P of n. So let P of n be the statement which is given by, we have sine of angle x added to sine of the angle 3x. This goes all the way up to the last term, which is given by sine of the angle 2n minus 1 times x. So this is going to be equals to, so we have sine squared nx whole divided by sine x. Right. So this is our statement. We have to verify that this is a true statement for all n belonging to the set of natural number. That means any natural number that we pick up, this must be a true statement. So let's first verify for n equals to 1. That means for the first natural number 1. So for n equals to 1, we have a statement P of 1. So when we say P of 1, we only have to consider the first term. Or what we can do, we can consider the nth term, and if we replace n with 1, that's going to simply give us sine x. So sine x, that's going to be equals to, we have sine squared. So in place of n, we have 1. So we have 1 times x, that simply gives us x. Divided by sine of x. So we can factor out 1 sine x from the numerator and the denominator. So this is simply going to be equals to sine x. So here we have showed that for the statement P of 1, sine x equals to sine x, this simply tells us that the statement P of 1 is a true statement. Fine. So we have successfully showed that our statement is true for n equals to 1 for the first natural number. However, we'll also have to show that it is true for other natural numbers as well. So here what we'll do, we will consider, we'll make an assumption here. So here we will suppose that let P of m. So let's say this is a true statement. So let P of m be true. Now what is P of m? P of m, this is simply the same statement as denoted by P of n. Only difference will be the n will be replaced with the letter m. So here we have sine x added to sine 3x. This goes all the way up to, so we have sine of 2 times m minus 1 times x. So this is going to be equals to sine squared m times x whole divided by sine of x. Fine. So let's call this statement number 2, and this is going to be a true statement. Now, taking the help of this statement, our goal will be to verify that if we consider the next consecutive natural number to that of m, which is m plus 1, so we'll have to verify that P of m plus 1, so that is also true. This is also a true statement. So how do we check that if it is a true statement or not? But before that, let's try to first write down what is the statement P of m plus 1 actually is. P of m plus 1, this is going to be, we have the first term sine of x, followed by the second term sine of 3x, going all the way up to the second last term, which is sine of 2 times m minus 1 times x. This is the second last term because we have to replace the m with m plus 1 to get the final term or the last term, which is sine of 2 times m plus 1. And this must be equals to sine squared m plus 1 times x whole divided by sine of x. So this is what we need to verify. So let's call it statement number 3. We'll have to verify that statement number 3 is a true statement. So for this, we will start from the left hand side of our problem. So on the left hand side, we have sine of x added to sine of 3x added to the rest of the terms. Coming to the second last term, we have sine of 2 times m minus 1 times x. Here 2 times m plus 1, so there is an x missing here, added to sine of 2 times m plus 1 times x. So this is going to be our left hand side. Now luckily for us, what we can do, we can take the first term all the way up to the second last term, and here we can replace it with sine squared mx over sine x. That's because 2 is a true statement. We've already considered it to be a true statement. So let's substitute the value with sine squared m times x divided by sine of x. This is going to get added to sine of 2 times m plus 1 times x. Now we have to combine these two terms, and we'll have to verify that this is exactly the same as the expression on the right hand side of statement number 3. Okay, let us do that. So this is a problem that is based on some trigonometric manipulation. What we'll do, from each of the two terms, we're going to take 1 over sine x as the common factor, when we're also going to take 1 over 2 as the common factor. This will become evident in a moment why I'm taking 2 as the common factor. Now that means we now have sine squared mx. This is going to be our first term, added to, so we also have the factor 2 multiplied to it, added to 2 times sine of the angle 2 times m plus 1 times x multiplied to sine of the angle x. Fine. Now here we can apply a formula here. So the formula being, so suppose we have 2 times sine of some angle A multiplied to sine of some angle B. Now this can be also expressed as the difference of the cosine function. That means we have cosine of A minus B minus cosine of A plus B. So this is a standard trig formula that we are going to use here. So here what we'll do, we'll consider the angle 2m plus 1 times x to be denoted by A and x to be denoted by B. That means we now have 1 over 2 times sine of angle x. So this is going to get multiplied to, we have 2 times sine squared mx. So the first term remains as it is. Now we have cosine of, we need A minus B. So 2m plus 1 times x minus x. So that's going to give us simply 2 times m times x. Fine. So this is going to be one angle minus cosine of, now we have to add the two angles. So that's going to give us 2 times m added to 2 times x. Fine. Now we need to further simplify. We're going to simplify cosine of 2 times mx. So here we're going to use the half angle formula. So cosine of 2 times the angle theta. So this is given by 1 minus 2 times sine squared half of angle 2 theta. So that's simply going to be theta. So that means we have now 1 over 2 times sine of angle x. So this is going to get multiplied to 2 times sine squared mx. The first term remains as it is. Now the second term, cosine of 2mx. So if we apply this formula, we're going to get plus 1 minus 2 times sine squared. We need half of angle 2mx. So that's going to be mx. And we have the last term, cosine of, let's take 2 as the common factor, m plus 1 times x. Fine. Now the first term and the third term that gets cancelled out. So now we have 1 over 2 times sine of angle x. We have the fourth term, the second term, which is 1 minus cosine of 2 times m plus 1 times the angle x. Fine. Okay, now again we can apply the formula. If we have cosine of 2 plus m plus 1, we can use this same formula, cosine of 2 theta given by 1 minus 2 sine squared theta, to rewrite the second term. So that means we have 1 over 2 times sine alpha. Our first term, so that remains as 1 minus, now we have 1 minus sine squared m plus 1 times x. Fine. So upon simplification, this is now going to leave us with 1 over 2 times sine of alpha. This is sine of x. This is not alpha. This is sine of x, sine of the angle x. Fine. So this 1 and 1 gets cancelled out. That means we now have, this is 2. There's a 2 missing here. So we have 2 times sine squared m plus 1 times x. Fine. So we can factor out this 2 and 2. And this is going to leave us with the final expression, which is given by sine squared of m plus 1 times x whole divided by sine x. And this is exactly the expression on the right hand side. Well, let's verify that. So we needed sine squared times m plus 1, sine square of m plus 1 times x over sine x. And this is exactly what we have obtained. So that means we were able to show that the left hand side of the expression, the left hand side came out to be equals to the right hand side. Now, if the left hand side equals to the right hand side, this means that our statement P of m plus 1, the one that we wanted to show is true, is actually a true statement, which means that here what we have done is we started out by considering the statement P of m. We assume that this is a true statement. And with the help of this statement, we are able to show that P of m plus 1, this is also a true statement. This is also a true statement. So what we can say, by the principle of mathematical induction, we can say that the original statement P of n, so this is going to be a true statement. And is it going to be true for all values of n? For all values of n belonging to the set of natural numbers. That means any natural number that we pick up, including m and m plus 1, the statement P of n, that is always going to be a true statement. So we have successfully verified our problem.